Okay, 8th graders, we are still doing section 2-4, but we are doing the part 2. So we did this part earlier, and I'm just going to finish up because sometimes when we solve these problems, we come up with these special cases and we have to deal with them. So we are going to treat these the same way we did the other ones. I like to simplify both sides of my equation first. So for example, on this side, I have an x minus 6x. So that's going to give me 4 minus 5x. On the other side, I know I can combine my 6 and my negative 2, which would give me 4. And then when I look at these, sometimes you might notice right here, all of a sudden these are the same equation. Well, if you have a minus 5x and minus 5x, the weaker link, it doesn't matter. I'm going to add 5x to both sides because we always move our variable first. And I have 4 equals 4. Does 4 equal 4? It does. So this is a true statement. So what this means is that no matter what number I put in for x, it's going to be true. And so the answer for this, you can either answer it infinitely, many solutions, or sometimes you see all real numbers. So what does that really mean? It means infinite. It means any solution, any number could be a solution. All real numbers means that any real number, decimal fraction, doesn't matter, would make the equation true. Okay, let's look at the next one. Again, is there anything we can simplify? Well, sure. Negative 8x, positive 9x gives me 1x plus 6. And then on this side, I have negative 17 plus x. Well, my x's are going to cancel out. And I get 6 equals negative 17. Is that true? It is not true. So this is a false statement. So this means that it's a no solution. You have to answer it either, infinitely many solutions or no solutions. You can't just say true or false. Next one, draw your line. 4y minus y gives me 3y. A lot of you guys are going to get good at these and you're going to notice, oh, these cancel. 7 equals 10. Does 7 equal 10? No. This is a no solution. Other side, 2c and c give me 3c. On this side, negative 14 and 21 give me 7. And I can see right here that these are going to be equal. But let's just go through the motions, subtract. Does 7 equal 7? It does. So that means that it's infinitely many solutions. Okay, the last type of problem. They like you to be able to take an application. So they like for you to be able to take make two equations. So it says the long distance rate of 2 phone companies are shown in the table. How long is a call that costs the same amount no matter which company is used? So same amount means equal. So they want to know, when is company A equal to company B? Okay, and then they give us the charges. So company A, it's 36 cents plus 3 cents a minute. So if I were going to express this in numbers, I would do 36 plus 3 cents a minute. I had to put them as decimals because we are working with cents. And the other company, company B, there's no charge, but there's a 6 cents a minute charge, so it's actually more expensive. So by solving this, we are going to find the m, the number of minutes, that makes each true. So I just like to clarify this. So this is the number of minutes. Then let's solve. I'm going to move this to the other side. This cancels. I have 0.36 equals, when I subtract these two, I get 0.03. Oh, hold on. Oh yeah, there's supposed to be an M on this one. Silly me. And then to get M by itself, I'm going to divide by 0.03. You're bumping the table. And then 3 goes into 36 12 times. And that accounts for your decimals. So in 12 minutes, they will be equal. Okay, and it says, what is the cost of that call? Well, what is the cost of a 12-minute call? We can put it into either companies. I'm going to do the 0.6, company B. So I know that 6 times 12 is 72. And then I'm just going to move that 2 decimal places. So it's 72 cents. Okay, and then you can also think of which one would be cheaper after 12 minutes. So the one that would be cheaper after 12 minutes is actually the one that has a cheaper per minute cost, because once you get to 12 minutes, you've kind of covered this 36 cents a minute, or 36 cents starting fee, or whatever they call it, and we're back to the cheaper per minute fee. So that is all.